Hello, good afternoon. Um, this is Shagun, engineer Shagun Dev Shagun. However, um, um, sorry about the delays we've been having lately, and I just thought we should make a micro class for those lectures that we're not able to meet up with. I think we missed about 5 lectures or so, 5, 6 lectures, due to the situation we had at the office. But we are doing our possible best to make sure we get rid of that situation and we get back to school. So what did I learn in this module? Previously we were discussing in introduction to this is module 13, the ARP process. Okay, so let me start from the beginning so that we're able to get we are not left or we are not left out on any information. So the website reading, why should I take this module? Hisori was looking at her phone and noticed that her phone actually has its own IP address. So she went home and noticed that the IP address had changed to a value that is different from the address that she had at the hospital. So she remembered that DHCP provides addresses to devices automatically. So she thinks that she gets IP addresses from different places depending on where she is. This makes sense to her because she knows these addresses permit devices to join different networks. Kisori also notices that her phone has a MAC address. She has checked and she notices that the MAC address is always the same, no matter which network she is attached to. So it makes sense to Kisori that her IP address changes when she is connected to different networks in different locations. But her MAC address is always the same because her phone is her phone no matter where she is. Okay, so that makes some sense. So this means that both IP and MAC addresses must be required in order for the phone to receive data. So the IP address tells the sender of the data where she is, and once the data gets to her location, the MAC address of her phone permits the device to receive data that is meant just for her. Thinking further, Kisori wonders how MAC addresses can be known to the network. DHCP provides the correct IP addresses for the network, but each device has its own unique MAC address. So Kisori is ready to learn more. Are you? Keep reading. So it just explains about the DHCP connection and every device having its own IP address, and most IPs on the same network have auto-generated. They all have the same IP address, DHCP IP address. As in, devices on the same DHCP network all have the same on the same network, and most of the MAC addresses are similar or are all the same. And moving forward, it says, what will I learn in this module? It says ARP process. Explain how ARP enables communication on a network. Topic title, MAC and IP. The topic objective, compare the role of MAC address and IP address. Broadcast containment. Explain why it is important to contain broadcast within a network. So moving speedily, ARP process. Okay. So what did I learn in this model? MAC and IP. Sometimes a host must send a message, but it only knows the IP address of the destination device. So the host needs to know the MAC address of both devices. The MAC address can be discovered using address resolution. There are two primary addresses assigned to a device on Internet LAN. Physical address, the MAC address, used for NIC to NIC communication on the same Ethernet network. Local address, the IP address used to send packet from the source destination device to the destination device. The destination IP address may be on the same IP network as source, or it may be on a remote network. So when the destination IP address, IPv4 or IPv6, is on a remote network, the destination MAC address will be the address of the host default gateway, which is the router. It says when the destination IP, IPv4 or IPv6 is on a remote network, the destination MAC address will be the address of the host default gateway. That is the router interface. So routers examine the destination IP address, IPv4 address, to determine the best path to forward the IPv4 packet. So when the router receives the Ethernet frame, encapsulates the layer 2 information. Using the destination IPv4 address, it determines to the next hop device and then encapsulates the IPv4 packet in a new data link frame for the outgoing interface. Along each link is in a path, an IP packet is encapsulated in a frame. So the frame is specific to the data link technology that is associated with that link, such as Ethernet. So if the next hub device is the final destination, the destination MAC address will be that of the device Ethernet NIC. So that is for the MAC and the IP. Moving forward, we're going to look at the broadcast containment. It says that a message can only contain one destination MAC address. Address resolution lets a host send a broadcast message to a unique MAC address that is recognized by all hosts. So the broadcast MAC address is a 48-bit address made up of all one. MAC addresses are usually represented in hexadecimal notation. The broadcast MAC address is in hexadecimal notation is FFF, FFFF, FFFF, 8 bit of 4 Fs and an octet, and um, 3 octets. So each F is a hexadecimal notation representing 4 ones in the binary address. So when a host sends a broadcast message, switches forward the message to every connected host within the same local network. For this reason, um, Okay. For this reason, a local area network, a network with one or more Ethernet switches, is also referred to as a broadcast domain. So if too many hosts are connected to the same broadcast domain, broadcast traffic can become excessive. The number of hosts and amount of network traffic that can be supported on a local network is limited by the capabilities of the switches used to connect them. So to improve performance, you may need to divide one local network into multiple networks or broadcast domains. Routers are used to divide a network into multiple broadcast domains. On a local Ethernet network, a NIC only accepts a frame if the destination address is either the broadcast MAC address or else corresponds to the MAC address of the NIC. Most network applications rely on the logical destination IP address to identify the local or of the location of the server and client. How does the sending host to determine the destination MAC address to place within the frame? The sending host can ARP to discover the MAC address of any host on the same local network. ARP uses three steps process to discover and store MAC address of a host on a local network when only the IPv4 address of the host is known. So the sending host creates and sends a frame addressed to a broadcast MAC address. Contained in the frame is a message with the IPv4 address of the internet destination host. So each host on the network receives the broadcast frame and compares the IPv4 address inside the message with its configured IPv4 address. The host with the matching IPv4 address sends its MAC address back to the original sending host. So the sending host receives the message and stores the MAC address and IPv4 address information in a table called ARP table. IPv4 uses a similar method known as neighbor discovery. So Webster reflection. All of my devices and all of your devices have an IP address and a MAC address. So when someone wants to send a message to my phone, my IP address tells the router where my device is. My MAC address is how my phone knows to let me see the message. That router also needs to know my MAC address and uses ARP to find it. Do you know how to look up the MAC address of each of your connected devices? I'm sure we know how to do that with our CMD file. When you're on the packet tracer, you know to go to bring out your computer. You go to the config. Under config, you You open the IP configuration, or you open CMD rather, and then when you open the CMD, you click on IP config, and then it's going to the machine is going to display the computer information to you. It's just like IP config, right? And then we'll be able to see media connected, Ethernet connected. We're not able to get the IP address, and everything here is blank. Why? Maybe because I don't have internet. I've been disconnected, so I have to connect back to. Oh my god! I hope it has been recording. So I want to go back and um, try IP config. Now I can see that I have on my wireless LAN, I can see my MAC address there, which is my link local IPv6 address, and I can see my IPv4 address there, which is my IP address. My subnet mask is to on 3 octet on the network, and then I have the default gateway, right, which is the supposed to be the router. I'm using since I'm using a hotspot. This is my phone, right? That is my phone IP. Okay, so let's continue. So we're able to see how we can get the MAC address from using CMD, right? So Webster reflection, we're going to do this quiz on our own, right? It's going to be part of our assessment, and then we would um, go back to it later, and we know how to make sure we have passed this. So let us do it, and then. So in the activity on number 10, there's the packet tracer activity. So I know that Auntie Fumi does not have this um, skills for all on her phone, on her computer. But now that they have merged it, if she has Network Academy, I think they have merged Net Acad and Skill for all. So there's a merge. So I think that same ID that you use for your Net Acad is going to open Skill for all, and you're going to be able to access this material that you're using.